Okay, welcome everybody. Today we're going to talk about, what are we going to talk about? Power functions and proportionality is what we're going to talk about today, okay? So, you guys can see we can jump right into warm-up problem A. If you're at home, go ahead and pause the video and you can complete these warm-up problems and then we'll talk about them together. Alright, let's go ahead and jump in. So warm-up problem A is a composition problem. They're asking us to find formulas for f of g of x and for g of f of x. Can I have a volunteer to help me figure out f of g of x? Yasmin? Wow, that's way too big. We gotta go down to a smaller size there. Okay, yeah, so I'm gonna do f of, and instead of x, in here I'm gonna write 1 over x plus 3, that's g of x. And then in my formula for f of x, anywhere I see an x, I'm gonna put 1 over x plus 3 in parentheses. Okay, that's all I'm gonna do. So I get 2 times 1 over x plus 3 squared plus 1. What do I have to do if I want to square this? Can I just distribute the square? No. What do I have to do instead? Foil. That's right. I need to foil this, okay? So this becomes 2 times 1 over x plus 3 times 1 over x plus 3. And when I multiply these two binomials, binomial means two terms, I have to FOIL. Okay, so plus 1 equals 2 times, now I'm going to write in here the FOIL. We're going to get 1 over x squared plus 3 over x plus 3 over x plus 9 plus 1. So if we multiply all that out, we get 2 over x squared. 3 and 3 make 6. Multiply by 2, we get 12. Plus 2 times 9, we get 18. I'm going to go ahead and add the 1 and get 19. That's how we find f of g of x. G of f of x is found in a similar way. We just plug in the formula for f in the denominator of right here. Okay, that's how we're going to find g of f of x. Okay. What about problem B? This is similar to ones we did in class last time. I'm going to do them for you guys since we did so many of these last time. Okay, so we're supposed to find f of g of 1. So f of g of 1 equals f of. Now what I'm going to do is I know x is 1, so I go find where x is 1, and then I'm going to go find the value of g when x is 1. That's 7. So g of 1 is 7, so I'm just going to replace the inside here with 7, because g of 1 is 7. Now I'm going to go find 7, and I'm going to find the value of f when when x is equal to 7. And that turns out to be 11. Okay, that's how I do that problem. We'll do the other one real quick. So what do? We want g of f of 3, so I find 3. I go to what f is at that point. That's 5, okay. Now 5 is x, and now I find g of 5. So then I go down to here, so I get 4. Okay. Any questions about the warm-up problems? Okay, compositions of functions will continue to be important for the rest of the class. We will do a lot of composing of functions later on when we talk about derivatives. So if you're not comfortable with them, I recommend that you attend my office hours today. Office hours from 11 to 1. Okay, and the link for the meeting room is on Blackboard. Okay, let's jump into the definition of power functions. So this is kind of a strange topic to me. I've never taught, quote, power functions before. Their uses, or the definition, seems somewhat useless to me, so I'm not going to focus over much on it. I'll just tell you that a power function q of x can be written q of x is equal to k times x to the power p, where k and p are real numbers. Okay, k and p are real numbers. Okay, so let's have some examples. Something like 2x squared. That's a power function. Negative 3x to the power 10. That could be one. Or we could get cheeky. We could do e times x to the power negative pi. That would be a power function. Why is it a power function? Well, e is just a number. So we're taking e times x to some power, and that power is also just a number. Negative pi means negative 3.1415, whatever. Okay, so that's also a power function. The other ones, so fractional powers, not a big deal for power functions, okay? Negative powers, not a big deal for power functions. It's just as long as the power on x is a number, a real number, which could be a decimal or a fraction or whatever, and we have some constant out front, it could be 1, or it could be any other real number, including 0, then we're going to have a power function. Okay? That's the definition of a power function. As I said, I think the applications of this are somewhat limited. What's much more important is the definition of a polynomial. We won't use Q, we'll use P of X. How about that? Polynomial P, let's not use P, let's use Q. Changed my mind, sorry. Q of X can be written as a sum, that means we're adding up things, of power functions, that says functions, let's do functions, with, and this is the important part, with non-negative integer powers. Okay, let's break down what that means. When I say non-negative, what I mean is p, the power, should be greater than or equal to 0. Okay? There's a subtle difference between non-negative and positive. Does anybody know what it is? Yeah, Ryan?
That you can use 0?
Yeah, inclusion of 0. 0 is non-negative, but it's not positive. That's the difference. Okay, so p is greater than or equal to 0. Integer means p equals something like 0, 1, 2, 3, 4, dot, dot, dot. These numbers, okay? All right, non-negative integer powers. So an example could be something like 100x to the power 7 plus pi x squared minus 17 equals q of x. Okay, so when I write this p here, I'm talking about the powers here, here, and implicitly here. What's the power of x which is attached to 17? Close? 0. Because we should have x to the power blank equals 1, which means that 0 should be the power. When we multiply it out, we get 1. Okay, but that's okay because we said that the powers should be non-negative. So having power equals 0 is allowed. Okay, that's how we get our constant terms here. Okay, so that's the definition of a polynomial. Polynomials are really important, and we're going to use them all the time in this class. So that's the bare bones definition. All right, let's do some problems. Okay, so we want to decide whether each of the following is a power function. If it is, state the values of k and p and write it in the form kx to the power p. Let's have group 1 work on problems A and B. Group 2 being basically just Mia and Michael, right? Work on problems C and D, and then everyone else, E and F. actually going to add something onto this problem. Determine also if it is a polynomial. Okay, also want you to determine that. Okay, would anybody like a little more time? You feel okay about them? All right, let's start with group number 1 on A and B. Who wants to help me out with A? Well, we're not feeling too confident.
So it is a power function?
Is a, whoops, that's the typing box. Okay, let's go back to the pen. It is a power function. Can you tell me what K is?
K would be
1. And what would P be? This is the tricky part, I think.
P would be -5.
Exactly, -5. We can write this as y equals x to the power -5. That looks a little bit more familiar in terms of our power function definition, right? We have x to some power, which is a real number. It's going to be a power function. All right. Do we think it's a polynomial? Anyone can answer. Ashlyn's shaking her head no. It's not a polynomial. The reason is, Ashlyn, can you tell me what the reason is?
Because there's not another something that's being added to it.
It's okay for a monomial, meaning one term function, to be a polynomial. What's not okay has to do with the power here. Remember, what did we say about the powers of polynomial? They should be non-negative integers. So this number is a negative integer. So it fails the test. It's not a polynomial. -5 is less than 0. Okay. Let's do problem number B. Someone else from group 1 want to help me out? Sam or Andrew or Uriel, maybe? Yeah, Uriel? It is a power function. That's right. We can write it as 14 times x to, do you know how we write the 7th root as a power?
1/7.
Exactly right, 1/7. Okay, we get 14 times x to the power 1/7. This is a power function. K is going to be our number out front, that's 14, and P is going to be 1/7. Okay. Did you have an opinion about whether it's a polynomial or hadn't got that far? I think it is a polynomial. It's actually not, and here's why. Remember what we have about our powers here. We should have non-negative integer powers. Do you see why the power is not satisfying this? It's non-negative, but it's the integer part, right? It's the integer part that's not being satisfied by this. So ES power, no poly. And the reason was 1/7, not an integer. I realize it's probably been a while since you guys have talked about the types of numbers: integers, rational numbers, real numbers, complex numbers. So yeah, integer just means like a whole number, but possibly negative. If we add the addition of it should also be non-negative, then we're talking about 0, 1, 2, 3, 4, so on and so forth. All right, group number 2, that's Mia and Michael and Aaron. What do we think about C?
I said it's not a power function
Not a power function.
because k equals 4 and p equals x.
Exactly. P, the power, is not a number, is it? That's the issue. Okay, this is not a power function. This is, does anybody know the name of this type of function? We just studied it recently. Yeah, you all got it. It's exponential. This is an exponential function. All right, how about D?
I think it is a power function.
Yes, it is a power function. And I think the tricky part here is figuring out what K and P are going to be. Did you get that far?
K2.
K is, you're close. We have to do something first. It has to do with these parentheses here. If we have two things being multiplied in here, do you know how we can get rid of these parentheses? Using this power here?
You can distribute it.
You can distribute it as long as we're multiplying in here. If we're adding and we're subtracting, cannot distribute the power. But if we're multiplying, we can do that. So if we distribute it, we would get 2 to the power 4 times x to the power 4. And now what do you think is K?
2 to 4.
Yeah, it's just going to be 2 to the power 4. So if we multiply it out, 2 times 2 times 2 times 2 times 2. Might have said that too many times. Then it's going to be, what, 4 times 4 is like 16, x to the power 4. So K is equal to 2 to the power 4, or 16 if you want. That's a really bad K. Let me redraw that. And P is equal to 4. Okay. Do we think that this is a polynomial?
Yes.
Yes. Resounding yes. The reason is the power is a non-negative integer. 4 is both an integer and non-negative. So we pass all the tests. So it's also a polynomial. Okay. Groups 3 and 4. What do we think about E? First of all, is there something that we should do first before we get going on answering whether these are going to be a polynomial or a power function? Yeah, Yasmin? Yeah, FOIL. So if we FOIL, we'll get x squared plus 3x, that makes 6x plus 9. Okay, and what do we think? Power function?
No.
It's not a power function. Do you know why?
Because there's not like a specific K or P.
Exactly. The crux of it really is we have three terms. A power function, remember, is k times x to the p. So we don't allow sums to be power functions. Power functions are just one constant times one power of x. So in this term we have three terms. We would call it a trinomial or something like that, or three-term polynomial. And we know that power functions have to be, quote, monomials, meaning one term. So because we have addition going on here, we're automatically out of the game for power functions. Okay, what about the polynomial classification? Does it apply here? Yeah, I'm seeing head nodding all around the class, so it is a polynomial. The reason being, each term has attached to the constant a non-negative integer power of x. On the first term, our non-negative integer power is 2. On the second term, our non-negative integer power is 1. On the third term, our non-negative integer power is 0. Okay, we don't write it there, but we can think of it as being times x to the power 0, which is 1. All right, how about the last one? I think this one looks tricky. Anybody want to give it a shot? Yeah, Ryan?
Yeah, that's what it was.
It is a power function, excuse me. Okay, and what's k and p? Do you know those?
K is 2/6.
And p?
Negative 1/2.
You nailed it. Negative 1/2. Yes, we can write. Move that over. We can write this as 2/6 times x to the power negative 1/2. Exactly. So it is a power function. Polynomial or not? Not a polynomial. Why?
It's negative and non-negative.
Yeah. It fails on both counts, right? Not a polynomial because negative 1/2 is less than 0 and not an integer. Okay? Okay. As I said, the polynomial part, much more important than the power function thing. Okay? All right, let's move on and talk about proportionality. Unless there are any lingering questions about problem number 1. If you do have questions, you can talk to me after class or come to office hours. All right, proportionality. We say, oh man, I better speed up a little bit. Okay, y is, quote, directly proportional, end quote, to x if y equals k times x for some number k. All right, it could be a real number, it could be pi, it could be negative 1 billion, it could be anything. Okay, that's what it means for y to be directly proportional to x, where y and x are variables here, and k is just a number. All right. They also say y is, quote, inversely proportional to x if y equals k divided by x. Okay, k divided by x for some real number k. That's what it means for us to be inversely proportional. Let's see here. Oh, shoot. Yeah, we better hurry up. Okay. George is buying a cart full of watermelons at the grocery store. The cost of his grocery haul is proportional to the number of melons. Okay, so that's the part I'm going to highlight. Cost is proportional to number of melons. Okay, so let's say that C is the cost and M is the melons. Okay, so what do we know so far? We say cost is proportional to the number of melons. So C equals K times M. C and M are variables. K is some number. What is the constant of proportionality? Okay, well, I better define what the constant of proportionality means. K is called the constant of proportionality. Okay, so our goal is to figure it out, and the information they give us is that he paid $79.80 and he left the store with 20 melons. So I'm just going to go ahead and plug those in. 79.80 equals K times the number of melons, that's 20. We divide both sides by 20, and we get K equals $3.99 if we used a calculator, and trust me, I did. Okay, and what are the units? Good question. Let's see, we're dividing a cost by a number of melons, so this is $3.99 per melon. Okay. All right, I'm going to move on. I'm going to skip problem 3. And we're going to talk about problem number 4. Unless there are questions about problem number 2. Okay. Problem number 4. Okay, Jenna and Kyle are moving across the country and need help packing up the moving truck. It takes 6 people 4 hours to pack up the truck. How long would it take 10 people, assuming that everyone works at the same rate? Okay. And the hint is that the time it takes is inversely proportional. Okay, so time is inversely proportional to the number of people. Okay, so let's call T time in hours. And let's call, I don't know, N the number of people. Okay, so if time is inversely proportional to the number of people working on the move, and I want to write some equation involving T, K, and N. Can anybody help me to write that down? Yasmin?
Would be T equals K divided by N.
That's exactly right. K divided by N. That was our definition for inversely proportional. Okay, so how are we going to figure out K? We're going to do the exact same thing before. We know that it takes 6 people 4 hours to pack up the truck. So 4 is going to go on the times side, so 4 equals k divided by the number of people was 6. So this is telling me that k is equal to, multiply out by 6 on both sides, I get 24. So I have the equation t equals 24 divided by n. That's my equation. The problem asks us to find out how long would it take 10 people. So in this case, I know the number of people but not the time. So I'm going to plug in 10 in for n. So I'll get t equals 24 divided by 10. And what do I get? 2.4 hours. Okay, that's how we do those. All right, if you want to see another proportionality problem, we can do it after class. Or in office hours or something like that. All right, quadratics. This is maybe the most important part of this lecture. So a quadratic equation q of x has the form q of x equals ax squared plus bx plus c, where a, b, and c are numbers, and in particular, a is not equal to 0. Okay, a should not be equal to 0. Otherwise, it's a linear equation, because we would just be left with bx plus c. Okay, so a is not equal to 0. Okay, I better add a page here, so don't get confused. I'm adding a page here, and this page is going to be used to talk about what I would love to be able to fit into this box, but there's no way it's going to happen. So this stuff, just imagine it going in the box. Finding roots of polynomials, quadratics, can be done one of two ways. Well, there's maybe there's more ways, but these are the two most common ways. We can do factoring. So, example, if we have, let me take a step back. I should explain what a root is. A root is a value of x that causes q of x equals 0. Okay, root is a value of x that causes the polynomial to be 0. Okay, so it's where it crosses the x-axis if we were to graph it. One popular way for doing it is factoring. Say we have x squared plus 6x plus 8, and we want to find the root. That means I'm going to set the equation equal to 0 and solve for x. Okay, so one way that I can do it is to write this equation as two things being multiplied together. Okay? The way I do that in this case is going to be x plus 2 and x plus 4. I'm assuming that everybody has seen factoring before, so if you haven't, come and talk to me after class. Just to refresh you, these numbers should add up to b, which in our case is 6, and multiply to get c, which in our case is 8. Okay, that's how we factor. And if we have these two things are equal to 0, if we have two numbers and we multiply them together and we get 0, at least one of them has to be 0. So we solve the equations x plus 2 equals 0, gives us x equals negative 2, or maybe x plus 4 is equal to 0, and that gets us x equals negative 4. Okay, so that's one way of doing our finding roots of these quadratics. The second way is using the quadratic formula. Which I believe there's a song that you can memorize to remember it. I don't remember it. I just remember the formula because I use it a lot. X equals negative b plus or minus the square root of, in here should go b squared minus 4ac all over 2a. Probably the most complicated formula that you've ever had to memorize. Okay, so let's practice on the same polynomial. So, in our case, we had x squared plus 6x plus 8. That means that a is equal to 1, b is equal to 6, and c is equal to 8. So let's plug. We get x equals negative 6 plus or minus the square root of b squared. That's going to be 36. Minus 4 times 1 times 8 divided by 2 times 1. Okay? If we simplify this out, we get negative 6 plus or minus the square root of 4 over 2, which is equal to negative 6 plus or minus 2 over 2, which is equal to negative 3 plus or minus 1. So we get x equals 3 plus 1 equals, equals negative 3 plus 1, which is negative 2, and x equals negative 3 minus 1 equals negative 4. Okay, so we got the same answer using both methods. There will be times where the quadratic formula has to be used because you can't factor the polynomial using integers. So you'll need to know at least the quadratic formula, and it will save you a lot of time to be able to factor if the polynomial can be factored. Okay. Any questions about how we find roots of quadratic equations? Okay. Let's do this problem here. We should have enough time to do it. Okay. Suppose a farmer has 20 feet of fencing. He wants to enclose a section of his ground that borders a river. The area enclosed will be a rectangle, but only 3 sides will be enclosed by the fence, as the other side will be bounded by the river. This question will guide you through the process of finding the maximum area that we can enclose. Okay, so first step, we're supposed to draw a picture of our situation. So I'll draw it up here. We could even use blue for the river. And then we'll use brown for our fence. Oh, look at that. Okay, sweet. So this is our setup. And we want to enclose the maximum area. Okay? So let's call this distance our width. And they say let x be the width. Okay, so this is x. How long is this part here? It's the same. That's right. It's also x. Why? Because if it wasn't, then it wouldn't be a rectangle. It'd be some kind of weird quadrilateral, but it wouldn't be a rectangle. Okay. So now we want to find an equation for the length. Okay, so I drew this too high, so I want to write something above it. Oh God, that's not what I wanted to happen. There we go. We'll leave it there. Yeah, I had to edit this problem. Okay. So my question is, what should this length be? Okay, if x is the width, we want to know how long that part should be. Well, the context of the problem tells us we have 20 feet of fencing. Let me ask you this. How much fencing did we use up on the two sides? 2x. So if I have 20 feet of fencing and I use up 2x, the amount that I have left is 20 minus 2x. Okay, that's how I figure that out. All right, so what's the area of the enclosed region? Well, we know the area is just length times width, so we get x times 20 minus 2x. Equals negative 2x squared plus 20x. Okay, that's how we figure out that area. All right, I got 2 minutes left, so I'm going to skip down to here. So we should now have a quadratic equation. Graph the parabola in part E in your calculator. Okay, this is wild. We're going out of Notability today and into the wild west of the internet. If we were to calculate this on our calculator, we would get a graph which looks something like this. Okay, remember x represents the width. Okay, so the way that this reads is over here, if we use 0 width, well, we get 0 area. And then as we increase the width, we get more and more area. But as we get really, really wide, the length has to become super, super skinny. And that causes our area to go back down to 0 as we get down here. Whoops. Okay, great. So last thing I want to do is find this vertex algebraically and interpret it in the context of the problem. So I know that negative 2x squared plus 20x is equal to 0 causes our roots to be, why don't we do negative 2x times x minus 10. This tells us our roots are at x equals 0 and x equals 10. So if I have a graph of a polynomial like this, and this part's 10, and this part right here is 0, what's the x value of the vertex going to be? 5. So x equals 5 corresponds to our vertex. If we plug in a of 5, we get negative 2 times 25 plus 100, and that gives us 50. So our vertex is 5, 50, and this represents the maximum area that we can enclose in our fence. Okay, so in particular, our width should be equal to 5, and our length should be equal to 20 minus 2 times 5, which means we should get 10. Okay, sorry for holding you 1 minute over. Class is over for today. Just a quick reminder, we have an exam coming up, not this coming Monday, but the following Monday. I'm going to send out a practice exam for you all that should be relatively similar to the actual exam And then on the day of the actual exam, well, I'll explain later what we're going to do on that day. Okay, but we're not going to have class.
Before the test, I hold a 2-hour review session, so it's longer, but
That's right.
I have them on Sundays, Tuesdays, Thursdays. I'll send out another email. I have a group me, and I'll send out again with like the link to the SI page that has every SI in case you can't make my sessions. You can go to another one.
Okay, so lots of SI sessions. Talk to Aaron if you want to learn more about that. Okay. Oh yeah, hi. By the way, you're back.
I'm back, yeah.
That's good.
2 weeks away, but
Yeah,
healthy and
that's good.
getting through it.
Yeah, I'm glad. I'm glad. Yeah, sure. You said another quadratic problem, right?
Yes.
Okay, let's see here. Here's one. Okay, so a ball is thrown into the air. Its height in feet t seconds later is given by this formula, which is a quadratic formula, right? We can tell that it's quadratic because we have a square here. Okay. So we're supposed to evaluate and interpret h of 2. Okay, let's do that. So h of 2, whoops. H of 2 is going to be equal to, well, we just plug 2 in, we get 80 times 2 minus 16 times 2 squared equals 160 minus 16 times 4, 64 equals 96. Okay. In terms of interpreting, we know that t is 2 and h is 96. So at time t equals 2 seconds, ball is 96 feet high. Okay. Solve the equation h of t equals 64. So this is going to be more what you're looking for, I think. H of t equals 80t minus 16t squared equals 64. So we want to know here, when is this equation going to be true? Okay. By this equation, I'm really mainly referring to this part. Okay.
What do you need to
We're going to get there. Before we can factor, there's one crucial thing we need, and that is 0 on the right-hand side. So first thing, we got to move the 64 over. Okay, we could make this problem a little bit easier on ourselves by dividing everything by, I think we can divide everything by 16. Yeah, because 80 is 16 times 5. So we can divide everything by 16. We get a new equation. What do we get? 5t minus, oh, well, why don't I put it in the right order? We get negative t squared. Why don't we divide by negative 16? Okay, the reason is I want this t squared to be positive. And then we'll have minus whatever comes from this guy, which is going to be 5t. And then we'll have a plus, and what's going to go here is going to be what comes from dividing 64 by negative 16, which is 4, equals 0. Okay, so we have t squared minus 5t plus 4 equals 0.
So in this particular problem, would it just make more sense to do the quadratic polynomial rather than factor? Can you even factor that? Or
Let's see. Yes, you can factor this. We want x minus a times x minus b. Well, why don't we make them pluses? And we want a times b equals 4. A plus b equals negative 5. And our goal is to figure out a and b. So let me ask you first, what numbers can we multiply together to get 4?
I would do 4 and 1.
Yeah, we can do 4 and 1. Okay, if I use 4 and 1 though, and I add them up,
It would have to be, both would have to be negative.
yes, exactly.
And multiply and positive.
That's right. If I use positive 4 and positive 1, then I would get a positive 5t in the middle. I have a negative 5t in the middle, but luckily, negative 1 times negative 4 is also 4. So the way that I factor this is x minus 4 times x minus 1 equals 0. If I have two numbers being multiplied together and I get 0, then one of them has to be 0. So the equations that I'm now going to solve are, I'm going to break this up into two cases. The first case is where the first number is 0 and the second one's not. That means that x minus 4 equals 0, which means that x equals 4. The second equation that I'm going to write down is the one where the left factor is not 0, but the right one is 0. So that means that x minus 1 is equal to 0, which means that x is equal to 1. Okay. So we solved the equation h of t equals 64. We found that h equals 64 when ... I switched to x's for some reason, but this should have been t's. T equals 4 or t equals 1. How do we interpret that in the context of the problem, which we're throwing a ball into the air?
So would that mean that 64 feet high would be anywhere between those two times?
Not quite. Here's how it's going to work. Here's me throwing the ball. Okay? And this line here, which I'll draw in red, is 64 feet above the ground. Okay, so this distance here is 64 feet. So, what this represents, it says that the height of my ball is going to be 64 feet high at 1 second after I threw the ball, and then again at 4 seconds after I threw the ball.
So it's just kind of explaining the curve.
Exactly. What it's saying is that my ball is going to go up, and it's going to go higher than 64, and then it's going to come down and pass 64 again. So what it's saying is that the x value here is 1, and the x value here is 4. Does that make sense? Or the t value. Don't know why I keep saying x. So that's what's really happening there.
Yes, that makes sense.
Okay. Now let me erase this part, this drawing, and we can do this part, this last part. When does the ball hit the ground after it's thrown? Okay, that's kind of a vague question. What do I want to solve here? I want to write down an equation based on this word problem part C and solve it. Ball hitting the ground. What does that tell you about this equation?
The height would be 0.
Exactly. Ball hitting the ground means h equals 0. Okay, so h of t equals 80t minus 16t squared equals 0. They're asking us to find when this equation is true, meaning find t that makes this equation true. Okay, so we can solve this. First of all, we can factor it by just pulling out a t. We can get t times, in fact, we can factor out negative 16t times what goes inside my parentheses. I'm going to flip-flop the order. I'm going to do this one first. Multiply negative 16t times blank to get negative 16t squared. What goes in the blank? Just t. And then I should have a minus sign, right? Because I divided a positive number by a negative number.
And that would just be
5, exactly, just 5. Okay. So, if this is equal to 0, then I have two contingency equations to solve. The first one is when this thing is 0, and the second one is when t minus 5 is equal to 0. So I'm going to go ahead and solve those equations. I got negative 16t equals 0. What should t be? 0. T minus 5 equals 0. What should t be?
Just 5.
5. Okay, so when does the ball hit the ground? 0 or 5?
5.
5. How did you decide on 5 and not 0?
Because the little, your spectacular drawing of the little
Yes.
person throwing the ball, I knew it was going to hit sometime after 4.
Okay, that's a good point. Yes, so we used some information from B to figure this out. Even if we hadn't done B, though, we actually don't need to necessarily use that information that is going to be after 4. What this says is that at time t equals 0, at the start, the ball is on the ground. Well, why is the ball on the ground at the start? Because I haven't thrown it yet, right? So that's why when I'm throwing it, that's when time is 0, and then after it leaves my hand, then time is going forward, 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 and then it hits the ground. So the reason that I choose this t equals 5, besides the fact that I know it was at height 64 at time t equals 4, is also just the fact that it should happen after I throw. Okay, so that's just some more factoring. Does that answer your questions? Did you want to see more like quadratic formula stuff?
No, I'm pretty familiar with that from high school. But,
Okay.
Yeah, I needed another problem to refresh.
Okay, cool. Well, that will be all for today.